In this unit, we're starting to look at circles, and with circles comes some vocabulary. So a chord is a segment whose endpoints lie on a circle. For example, segment BA, segment BD. Those are chords. A central angle is an angle whose vertex is at the center of the circle. So ACD is a central angle. ACD here is also a central angle. And an inscribed angle is an angle whose vertex lies on the circle, like angle B here, and whose sides contain chords of the circle. So AB and DB are chords of the circle. ABD is an inscribed angle. I do, however, want to call your attention to the prospect that BAC is also an inscribed angle. Even though segment AC is not a chord, I could extend this, and now you see that the side AX contains AC, which is a side of that angle. Okay? The book has this explore activity that it wants us to do, and I tried to do it using my dynamic software, and it didn't work out the way I wanted it to. And so I'm going to kind of jump around in the notes a little bit. I hope you'll bear with me. So back here, they're explaining that an arc is a continuous portion of a circle consisting of 2 points and all the points between them. Just like how a line segment is a part of a line that contains 2 points and all the points between them, similarly, this is arc AB, and it contains the point A, the point B, and all the points on the circle between them. Okay, so in this instance, AB is a minor arc, okay, because it is less than 180 degrees. A semicircle is an arc. I don't know what's up with this. This is ADB, arc, ADB. It is a semicircle. Its arc, or its measure, is 180 degrees. Arc ADB in this diagram, notice, starts at A, goes through D, ends at B. It is greater than 180 degrees. Now, your book has it described as having measure 360 minus this. And the reason is because the measure of an arc is the same as the measure of its central angle. Okay, so if I know that the measure of this central angle is 60 degrees, then I know that the measure of arc AB would also be 60 degrees. Okay, so that's central angles. Inscribed angles, however, it's a different relationship. And so in this activity, what they wanted you to notice is, for example, in this instance that I had, if I had drawn an inscribed angle ACB, and this circle, central angle AOB, notice this angle is significantly smaller. Okay, so if I had actually done this using my dynamic software, I might have had that this angle would be 30. If I had been able to do this with my dynamic software, for example, here, ACB, this central angle would be 120 degrees. This angle would actually also be 120 degrees, and here's why. Because this arc would measure 240. And so the relationship that they're wanting us to notice is that the measure of an inscribed angle that is 90 degrees or less is half the measure of the central angle intercepting the same arc. Now here, for example, what would have happened had we done the activity, well, what we would notice is that the central angle is 120, and that 360 minus that central angle would be 240. So the inscribed angle is half of 360 minus the central angle. So when an inscribed angle is greater than 90 degrees, its measure is half of 360 minus the central angle. And I will clarify this in an easier way momentarily. A little bit more vocabulary. Adjacent arcs are arcs intersecting at exactly one point. So for example, DE and EF are adjacent arcs. Think way, way, way back to Module 1. We had such a thing as segment addition postulate that said that AD plus DB equaled AB. And then we also had the angle addition postulate, which said that the measure of angle ABD plus the measure of angle DBC equaled the measure of angle ABC. You may recall that I broke this down to part plus part equals whole. Same exact thing happens with arcs. So, in example 1, we have in part A that the measure of angle BCD is 18. The measure of arc EF is 33. So we're trying to find the measure of arc ABD. Well, if arc EF is 33, then angle ECF is also going to be 33. So that means that ACB will be 33 because they're vertical angles. So therefore, arc AB is 33. If angle BCD is 18, then arc BD is 18. And therefore, the measure of arc ABD is 51. Just add them together. Similar idea in part B. If the measure of arc JK is 27, determine the measure of arc NP. Okay, well, if this arc is 27, then angle JCK is also 27. So if JCK is 27, then the measure of angle MCN is also 27 by vertical angle theorem. So since angle MCN is 27 and the measure of angle MCP, notice, is 90, then the measure of angle MN is 27. The measure of angle MNP is 90. So by the arc addition postulate, MNP equals MN plus NP, I know the measure of the measure of NP will equal the measure of MNP minus MN. Well, measure of MNP is 90. Here's a nice thinky problem. I have that the minute hand is moving from here to here. It's asking for the measure of the arc that it's moving from 310 to 330. So it's asking for the measure of this arc. Okay, so it's 360 degrees all the way around a circle. And each number on the clock, well, there's 12 of them, so let's figure it out. 360 divided by 12 is 30 degrees. So the minute hand moves 30 degrees every 5 minutes. There's 1, 2, 3, 4 5-minute increments between 310 and 330. So 4 times 30 equals 120 degrees. I mentioned earlier that I would make the concept of the measure of an inscribed angle a little bit clearer, and notice how the book does it for us. So an intercepted arc, I mentioned earlier about Pac-Man eating an angle. The intercepted arc is the arc that the angle is eating. So an inscribed angle is going to be half of that intercept. So let's use the inscribed angle theorem to find some measurements. In part A, it says by the inscribed angle theorem, we know that angle DAE will be half of arc DE. Well, I don't know arc DE, but I do know angle DAE. So that's why they doubled the angle to find the arc. By arc addition postulate, I know that arc BD equals arc BE plus ED, so that's why they have 18 plus 108 to get 126. By the inscribed angle theorem, DAB will be half of arc BD. We just found arc BD to be 126, so they took half of that to get 63. Note that arc ABE is a semicircle, so arc ABE is 180 degrees. And by the inscribed angle theorem, ADE is going to be half of arc ABE, which is intercepting, so half of 180 is 90. Let's use the same thinking in part B. By the inscribed angle theorem, angle WZX will be half of arc WX. Well, I don't know arc WX, but I know angle WZX, so that's why they doubled the angle to find the arc. Note that angle WXZ is a semicircle. Therefore, WXZ is 180 degrees. By the, what property? WXZ equals WX plus XZ. That's the arc addition postulate. Then arc XZ equals 180 minus 18, which is 162. So by the inscribed angle theorem, angle XWZ is going to be half of arc XZ, which we just found to be 162, so they took half of it to get 81. Note that arc WYZ is also a semicircle, and so its measure is 180 degrees. So by the inscribed angle theorem, WXZ will be 1/2 of the measure of arc WYZ. So it's half of. In this reflect problem, it's asking for an alternative method to determining the measure of arc XZ. This is a typo. Well, I know that arc WYZ, all of this, is 180 degrees. I know that this is 18 degrees, so we could have done 360 minus 180 plus 8 and gotten the same 162 degrees. How does the measure of angle ABD compare to the measure of angle ACD? Well, the measure of angle ABD equals half of arc AD. The measure of angle ACD equals 1/2 of the measure of arc AD. Oh, hey, look at that. These two right sides of the equations are equal. So that must mean that the measure of ABD equals the measure of angle ACD, which should just make sense. They're both inscribed angles. They're both intercepting the same arc. That makes them congruent. In this your turn example, I know that angle EDF is 15 degrees. And it's asking me to determine the measure of angle ABE. Well, if angle FDE is 15 degrees, then the measure of arc EF will be 2 times that 15, making it 30. I'm asked for the measure of angle ABE. Measure of angle ABE will be half of the measure of arc AE. The measure of arc AE will be 44 plus 30, which is 74. So the measure of angle ABE equals half of 74, which is 37. In Explain 3, they're wanting us to use a compass, make a circle, draw an inscribed angle on a diameter, and here's what they're describing. So I'm just going to kind of sketch it. I have center C and diameter DF, and here now is inscribed angle DEF, and it wants me to measure that angle. But we've already seen before that when I have a semicircle like DAF, its measure is 180 degrees, and when I take this inscribed angle and I use the inscribed angle theorem and take half of 180, I always get 90. So no matter how many times I do this activity, I would end up with. It's asking me to make a conjecture about the measure of an angle inscribed in a semicircle. The measure of an angle inscribed in a semicircle equals 90 degrees. How does the inscribed angle theorem justify my conjecture? A semicircle measures 180 degrees. Inscribed angles equal half the intercepted arc and 1/2 of 180 is 90. Which we have right here. So I have a right angle inscribed in a circle. If the endpoints of its intercepted arc are connected by a segment, must the segment pass through the center of the circle? Yes. If I take the inscribed angle, 90, and multiply it by 2, I have to get 180. So the intercepted arc is a semicircle, and a semicircle is formed by a diameter.